I myself, Ajay Kumar Panda, belonging to this Computer Science and Engineering Department, Post Kotak. Today we will discuss this functional dependency in DBMS. This is perhaps in unit number 3 in database management system. It is very important for understanding these things, and once you understand these things, then it is become easy. Now, before going to this functional dependency, first let us consider this function y is equal to fx. So that is the function, so 2x minus 1. So if you put this x is equal to 1, then y becomes this f of x, f of 1 is equal to y is equal to 2 into 1 minus 1 is equal to 1. Then x is equal to 2, then f of 2 is equal to y is equal to 2 into 2 minus 1 is equal to 3. So from this we conclude that the value of y depends on the value of x. So this y depends on the value of x. Now if we got it this x is equal to 1, then y becomes 1. Then if we got it this, if we x is equal to 2, then y becomes 3. Then accordingly we follow it this one. So like this, it is our arithmetical, so mathematical function. So in your functional dependency, again you consider another function in our mathematical function, y is equal to fx is equal to x square. Let it be x is equal to minus 2, x is equal to plus 2. Then f of 2 is equal to y is equal to plus 2 of square is equal to 4. Then x is equal to minus 2, f of minus 2 is equal to y is equal to minus 2 of square is equal to 4. From this we conclude that x is equal to plus 2, then we got it y is equal to 4 and x is equal to minus 2, y is also this 4. And this different values of this x, we got the same value of y, but in this case, the different value of x, we got it the same different value of y. But whenever we got it, if we put it any value onto this value of x, definitely we got it this value of y in a constant value. And at any time, irrespective of the time and this geographical situation. Now, this is our main function, mathematical function. Then come to our functional dependency. Functional dependency. Now, within this functional dependency, let us consider FD is a functional dependency from alpha to beta. So FD this is a functional dependency from alpha to beta. This alpha and beta are the attributes in the database management system. And your database table, in a relational table. Now, this FD is a functional dependency of two attributes. We consider these two attributes, alpha and beta. This one, alpha and beta. Then this is a table, and this row is called as the tuple. This row is the tuple. This first tuple. This is second tuple. Tuple 2, and like this, tuple 3 like this. Now, suppose if we put it any value of the alpha, then correspondingly we got it the value of beta. This is your table or relation like that. So name of this table is R. So this R contains, let us consider two attributes. It may be more than this two attributes. For easier understanding, we consider this two only for understanding. Let me say that. Suppose for A, B, C, D, the value of alpha, let it be A. Then the corresponding the value of beta will be 1. Suppose the value of alpha is equal to b, then the corresponding value of the beta will be 2. Let it be the same c, then it will be 3. Then this d, it will be like that. This is a tuple, this one is tuple 1, tuple 2, tuple 3, tuple 3. That means row number 1, number 2, row number 3, row number 4. And from this we conclude the value of this alpha, all are distinct, that means unique. All are distinct to each other. Then this value of this beta will be this distinct also as per our given data. If someone is asking, suppose if the value of alpha is b, then what will be the value of beta? Then definitely the value of beta will be 2. Everyone understand? Then if suppose this becomes E. If I ask, so if the value of alpha is A, then what will be the alpha of beta? If the value of alpha is A, then what will be the alpha of beta? That is the confusion. Because this alpha, whether this value of A is either 1 or 2, so that is the wrong. So always you should maintain this one in such a manner that the value of alpha, if you consider a constant value, that cannot make the two different values in the beta. This creates the problem on that. So this is our functional dependency. Whenever this functional dependency FD such that from alpha to beta, for a value of alpha, we got a unique value, we got a single value for the beta. If we got the two different value, then it is not a valid functional dependency. So from this, it is not a valid functional dependency from alpha to beta. If the alpha is A and the value of beta is different on this case. Then come to this one. Now, let me give you more formal definition of this one. That is, suppose alpha and beta. Alpha is the subset of this table R, and beta is the subset of the table R. Now, if this FD is a functional dependency from alpha to beta, this alpha to beta is a functional dependency if tuple T1, suppose if tuple 1 of alpha is equal to tuple 2 of alpha, that means T1 alpha, if it is A, and if it is T2 of alpha, if this is true, if this is same, then it should be, this implies it should be tuple of beta should be equal to the tuple 2 of beta. So in this case, it should be 1. Then we say this is a functional dependency from alpha to this beta. So this is your formal definition or a mathematical definition of this functional dependency. Mathematical definition of the functional dependency. Now, if FD is a functional dependency from alpha to beta in a relational table, then I will tell the value of alpha, then you can get the value of beta from this. So from this, previously in our mathematical things, suppose y is a function of x, we can compute, if you put it the value of x, we got it the value of y. If the value of x is 2, we got it the value of y is, let it be 3. Then if we put it the value of x is 3, then value of y maybe suppose 5. That is the mathematical. From this we can simply compute from this one some any type of expression, algebraic expression. Algebraic expression. That means we put it, the value of this one, suppose let it be for 2x minus 1, y is equal to 2x minus 1. If we put it x, then y is equal to 1. If we put it 2, 4 minus 1, 3. If we put it 3, then it will be 5 like that. That means if we put the value of x, that will be computed into the expression, then got it the value of y. But in case of a relational table, all data are given onto that table. We can, instead of computing these things, we can search from that table the data of that corresponding data of the beta. Right? So that is how we say that is a functional dependency of this one, from alpha to beta. That means this is your determinant and this is called dependent. This is your alpha is called as the dependent and beta is called as the dependent. And so from this, it is only the matter to search or to identify or to find or to get the data from the table instead of computing like in your algebraic expression. It is not like your algebraic expression. All data are given. If we say what will be the value of if this alpha, the value of alpha is c, so what will be the alpha of beta? Beta is 3. But not any type of computation on that. Simply we search from the table what will be the data of the corresponding data of the beta of the value of alpha is c. So this is how we say it is called. So in our practical point of view, in the real world, we can say, suppose in your student database file, so student ID is there, suppose table is there, I will consider this one, these two are attributes, student ID, another is your, suppose student name. Number of attributes are there. We consider these two like your alpha beta. Suppose alpha means your student ID and beta means it is a student name. Number of attributes are there. And let me read. This is your student attributes 1001. Name is suppose X. Whenever suppose 1002, name is X1. 1003, name of the student is your suppose X2. Now this relation or table is called as a student table. This is the student table like this R, and within this student table, what are the attributes? Student ID, student name, like your R of alpha and beta. From these two fields are there. From this also we consider this. We consider the student ID and student name. All these respective data of this field name are filled by the data entry operator. Now we see in a real world practical scenario in the real world, if the student ID is your 1002, what is the student name? Student name is X1. It is not computed from this one. Simply we verify this one, we search it. The value of student name in the corresponding student ID is your 1002. The name of the student name is X1. It is simply to find out, only to search instead of computing this one. That's why we say using the value of alpha, we can simply search the value of a beta from the table, but not any type of computation or not to any type of calculation on that. Simply to search only from that. So that is the functional dependency within that. Then this functional dependency in DBMS is a relationship between the attributes of a table. Attributes, these are the attributes. Alpha, beta, like that student ID, student name. These are the field name or alternative name. These are the attributes. Between the attributes of a table dependent on each other. All are dependent because this 1001 that depends on the student name X. Then depends upon the if branch is another attribute. Then branch is suppose CAC. Then this one is dependent on this one like that. And each other. Functional dependency is a constraint to determine the relations of one attribute to another attribute in your database management system. Or it is a relationship that exists of one attribute uniquely determined by another attribute. So what it helps? It helps in preventing this data redundancy. Most important is you are preventing the data redundancy. That means to reduce the data duplication of this data. This makes very most important point for this your functional dependency. And this it helps to maintain the quality of data in the database. That is the quality. Then this can be represented. Suppose if alpha is alpha from alpha to beta, that will be represented by alpha, this, then beta. That is, if column A of a table uniquely identifies the column B of the same table, then it can be represented as A arrow mark B, and this attribute is functionally depend on this B. This B is functionally depend on the attribute A, and this it exists between the primary key and non-key attributes within the table. And this left-hand side, this is your symbol on the left-hand side. This is called as the determinant. This alpha is the determinant or A is determinant. In this case, student ID. This will determine the name of the student. So this is the determinant and this is the dependent. So as per the data of the student ID, we can get it the student name correspondingly. How do you write this functional dependency from a table? Suppose student ID attribute uniquely identifies the student name. Attribute of student table. This is our student table. In this case, different attributes are there. Student ID, student name, branch, date of birth, mobile number, like that. Right? Now student ID and student name. This student ID correspond to the student name. And it is known as the functional dependency and can be written as STUID, this student name. And in other words, we can say student name is functionally, this student name is functionally dependent on the student ID. Then another is your partial dependency. It is most important in case of while studying this normalization. And partial dependency is a form of functional dependency that holds in a set of attributes, like suppose consider this PQ. PQ produces R. PQ produces R. If only P produces R and only Q produces R, then this is called a partial. Part of this is fully, and if P produces R, that is the part of the PQ. This PQ is the part of the PQ, so that this R depends on the part of the PQ, That means either only P or Q. That's why it is written as either P alone or Q alone. Uniquely identify R. If this R is identified either by P or Q instead of PQ, then it is called as partial dependent. And previously it is fully dependent on that. If P uniquely identify this R, then it is called as the partial functional dependency. This is called as if PQ tends to R, and if either this P or Q individually can identify this R, then we say it is called as a partial functional dependency. Then transitive dependency. Transitive dependency, like that, consider if X is equal to Y and Y is equal to Z, this indicates X is equal to Z. So this property is called as the if X to Y, Y to Z, then X is equal to this. This property is called as the transitivity. Transitivity. Like X is greater than Y is greater than Z, then X is greater than Z. That is the transitive property under. So in this case, functional dependency is said to be transitive if it is indirectly formed by two functional dependencies, like X depends this, Z depends on this X, that means X produces Z, is a transitive dependency if three functional dependency holds good. That means X produces Y, but Y doesn't produce X, and Y produces Z, then X produces Z. X produces Y, Y produces Z, then X produces Z. So X produces Z is a transitive dependency. Like, for example, in this example, yes, this is our book table, book name, author, authorized. Name of this book name of the book is this Game of Thrones. This author is written by this Martin. This age of this author is 66, 45, 66. From this book produces author. Whenever we purchase this one, definitely we got it what is the author written onto that book. So this book produces this author. That means author depends on the books. And if you know the book, then we can get it the author's name. Author does not produces the book because one author may write more than one book. So author doesn't produce or identify a particular book, but book always identify a particular author, because in each and every book, the author is written onto that. So always book indicates the author name, but reverse is not true. And then author produces author age. Therefore, book produces author or indicates author. Author indicates author age. This implies book produces author's age. That is the transitivity functional dependency. Another example. Multi-valued functional dependency. If it is more than one, suppose this is one value. This is your worksheet in your Excel sheet, like that in your table, or you consider this one table, and within this, all these are the single cell. Within this single cell, one value, this cell one value, this cell one value, this cell one value, this cell one value, but this cell has more than one value. This has more than one value. Color is black and red. That is called as a multi-valued things. And we divide this one M1001 with manufacturer 2007, M001, 2007. Color is black and another same thing repeated. Then we put it in red, black and red. These two times we write it and then put it this red. Then again this one 2008 black red, like that, 8, 9 black red, and this one. This is our multi-valued dependency. In this case, consider a bike manufacturer company which produces two colors, black and white, in each model every year. And in that case, whenever is only single value dependency or functional dependency, only one arrow mark is there. If it is a multi-value dependency, bike model depends on the number of manufacturers. That is a double arrow mark manufacturer here. Manufacturer here is double valued as there, multi-valued as there. So in that case, multi-valued. This will be represented by this double arrow. Then bike model is also produces the more than one color onto that. That's why black, red like that, double arrow mark on that. So this is our multi-valued function. Now, come to this one. This is our assignment onto that. Consider which of the following functional dependencies are valid in the given relational table R, A, B, C, D, E. That means, previously I have told you this, student is the table name. Within this, all these are the attributes and separated by same comma and enclosed with your parenthesis. So, this is your table name A, B, C, D, E. How many attributes? 1, 2, 3, 4, 5. 5 attributes within this. Now R of A, B, C, D, E. So these 5 attributes are there. All data are given. Now which of the functional, this is a functional dependency. A produces BC, DE produces C, C produces DE, BC produces A. Now we find out which of the following, how many functional dependencies? 4 functional dependencies. One functional dependency, this is another, this is another, this is. 4, out of these 4 functional dependency, whether all are functionally for dependency or valid or none of the functional dependency is valid. Now we verify it. This is a multiple question on that. So from this, A produces BC. Consider, come to this, the value of A, the value of this A is now A. Now produces BC, means 2, 3. Identifying the value of A, the value of A, that is A produces 2, 3, right? Then this 2 produces 2, 3. These 2 are different, this doesn't depend on this one. Then the value of A is also 2, 3. Same thing, 2, 3, 2, 3. Now again, this is A, the value of A is A, then 2, 3, 2, 3. So it is a valid statement. A of A, this BC, this functional dependency is valid because this A produces the same data, 2, 3, 2, 3, 2, 3. So this is a valid functional dependency. So now this is valid, holds good on that. Now come to this DE. DE produces CE. Come to this one. DE 4, 5 produces E. Okay, 5, 3. Then 4, 5 produces 3. That is also okay. Then DE 6, 5. It is also produces. I have told you this in your this alpha. Come back to this original one. Value of alpha, we can search the value of beta from the table. Search the value of beta from the table. So we cannot from this D, this 4, 5, that is 3, this 4, 5 is also 3, and that is same, and 6, 5 is also 3. That is valid because this alpha, this 2, 6 and 5, that same different value may point to this same value to that. So that is also valid. 6, 6 is also 3. So DE produces this one, C, that is a valid functional dependency. Then come to CDE. C produces DE. Now C produces DE, 4, 5, 5. Then C produces DE, 5. It is also a valid statement. C, 3 produces 6, 5. It is wrong. Like suppose for example, previously 1002. If 1001, it is 1001. Student ID, name of this, registration number or student ID is 1001. Name of the student is X. Again come to this. Student ID is again 1001. The name of the student is X1. That is the wrong with you. Because having with the same student registration number or student ID is unique only one, then student name should be same. But in this case, this CDE means C produces DE means C produces a DE 4 file, these 3 produces or identify 4 file, these 3 identify this 4 file, these 3 identify 6 file. That is a confusion. So this C produces DE, that functionally, this is not a functional dependency, and this functional dependency, it doesn't hold good on this C tends to D. Then come to this BC tends to A. BC produces A. BC 2 3 2 3 2 3. 2 3 produces A, 2 3 produces A, 2 3 produces A. That means that is a valid A3 produces 2. That is something different because 2 3 this is A3. Totally different. It may produces the same data or different data. But now this 2 3, this 2 3, this 2 3 produces the same data. That's why BC produces A. This functional dependency is valid and this is false good. So from this, a multiple choice, if it is more, 4 multiples are there, which one is a valid or which one is a non-valid functionally dependency? And C is the answer, that is the multiple choice of this one. Right? So this is our functional dependency in DBMS. So mind it, same value of A. If we get the different value of BC, then A produces BC is not a valid functional dependency. Actually, this is not there. If we get the different values of BC, like in your C, so this C produces DE is not a valid or it is an invalid functional dependency. This is our functional dependency in DBMS. Thank you.